Hello and welcome to this new tutorial. So in the previous tutorial we introduced our blockchain by initializing it with two variables, self.chain, which so far is an empty list, but to which we will of course append the different blocks that will be mined later on, and the genesis block. The genesis block that we created thanks to this createBlock function with a proof of 1 and a previous hash of string 0. And so of course now what we need to do is to create this createBlock function to not only be able to get really this genesis block, but also to be able to create the next blocks once they're mined. And that leads to the first very important difference we need to understand. It is the difference between the createBlock function that we're about to make and the future mineBlock function that we will build at the end of this module. And the difference to understand is that we apply the createBlock function right after mining a block. The mineBlock function will simply get the proof of work that we will need to solve, so we will define the problem and we will define the algorithm to find that proof of work. And then once we find this proof of work, then that means a new block is mined, and that's when we can create a new block and add it to the blockchain. So this new createBlock function that we're about to make will not only create the block with all the different features like the index, the timestamp, the proof and the previous hash, but also will append this new mined block to the blockchain. And so that's exactly what we'll do now. We'll define this new createBlock function that will create this block and add it to the blockchain. So according to you, the first question now is, what arguments will this createBlock function take? So first, it will take self, because of course we will use the variables of our object. But then, what do you think it will take as arguments, considering what I've just explained? That is, we use this createBlock function right after a block is mined. So since it's right after the mining of a block, well, naturally we will take the proof, because that's exactly what the mineBlock function will give us. It will give us the proof based on the proof of work problem that we'll define later on. So proof, and then what is going to be the next argument? I can already tell you there is two arguments. Well, the other one is actually a very important element that links the previous block to this new block that we're creating, and that was just mined. So as you might guess, this argument is the previous hash. The previous hash is the key element that links two blocks in a row in the blockchain. So previous hash, and that is why, same here, we took exactly the proof and the previous hash for the genesis block. It's going to be the same when we create a new block. We will get the proof that was found or solved by using the mineBlock function that we'll make later on, and the previous hash, which is the hash of the previous block. So createBlock, taking as arguments self, proof, and previous hash. And now let's define what it has to do. So what it has to do is very simple. It's just to define the new block that was mined. So what we'll do first is introduce this new block variable, and we're going to make a dictionary. We're going to make a dictionary that will define each block in the blockchain with its 4 essential keys. These 4 essential keys are first the index of the block, then second the timestamp, which is the exact time when the block was mined. Then third, the proof of the block, which is the proof that was found when mining this new block. And eventually, the previous hash. But you can actually add anything else, anything you want inside this dictionary. And that's exactly what we'll do in this module 2. In this module 2, we'll add some data in this block that will be the transactions of the cryptocurrency that we'll make, and that I remind is called Hatcoin. And so this is to show you that right now we're creating a general blockchain in which you can add anything in a new key that you could call data. All right, so let's include these 4 keys, and then we'll simply append this new block to the blockchain and return this block, because we will want to display it in our user-friendly interface, Postman. All right, so let's start with the first key. We said that the first key was index, that we have to put in quotes because it's the key identifier of the dictionary. So index, and how will we get that index? Well, that's easy. We simply need to take the length of the chain that exists right now. Right now it is an empty list, but when we add some new blocks, it will get a non-zero length. And so to get the index of the blocks, well, simply we can take the length of the chain plus 1. Because suppose the chain has 10 blocks, well, the new block will have index 11 because this is the 11th block. All right, very simply. So we take the length of the chain, and we have to specify self here because the chain is a variable specific to our object, attached to our object. So self.chain and plus 1. Perfect. Now, next key. So the next key is, as we said, the timestamp. The timestamp, that is the exact time when the block is mined. And to get this time, well, we will use, of course, our datetime library that will give us exactly the year, the month, the day, the hour, the minute, and the second when the block is mined. And to get this exact time, well, we simply need to take first our datetime library. Then we take from this datetime library the datetime module. And from this module, we take the now function, which will return exactly the time it is in real life when we call the function. And we will call the function exactly when we mine the block. All right? So datetime.datetime.now, all good. And now, almost all good, we need to put that in a string. A string, otherwise we will have some format issue when working with the JSON format. So timestamp, datetime.datetime.now in string. There we go. Let's move on to the next key of our block. So the next key is an essential one, the proof. The proof that we get when mining our block by solving our proof of work. So proof, and this proof will be, of course, the proof that we take as argument in this createBlock function, and more specifically, the proof that we get after solving the proof of work. So that means that later on, actually in 2 or 3 tutorials, we will create the proof of work function that will return exactly the new proof of a new block that we mine, and this new proof is exactly this proof that will input as argument of this createBlock function. So far we only need to, well, specify this argument, proof, but rest assured we will make this proof of work function later on to get that proof. All right, and one final key, the previous hash, which is the hash of the previous block, and which is the essential element that links 2 consecutive blocks in the blockchain. And again, of course, this previous hash is going to be the argument so far. And to get this argument, well, we will simply take the hash of the previous block when this chain will be populated with the blocks. So far, just the argument, previous hash. And there we go. We have the essential keys of the block. And then, if you want to add any data inside the block, so right now we're making a general plain blockchain, but in the next module we'll add some data, which will be the transactions of the cryptocurrency. To add some data in the blockchain, you can simply add a new key here, which would be, for example, data. And attached to this key, you can just include anything. You can put that in a JSON file. I will show you how to do this in module 2, or you can simply put some text in whatever format you want. That's up to you. But we won't be doing this in this module 1 because we simply want to create a general blockchain, and therefore we're only going to use these 4 keys, which will define a block in our blockchain. And now that we have a block, well, we of course need to append it to our chain. And to append it to our chain, it's very simple. Since chain is a list, we simply need to take that list, chain, and then use the append function to append this block that we just created. And that's it. And then we also want to return this block because, as I told you, we're going to display the informations of this block in Postman. And by informations, I mean, of course, the 4 keys here. All right, and that's it. We just defined this createBlock function that I remind will be used right after solving the proof of work, that is right after mining some block. And so what will happen is that we will apply this createBlock function at the end of a future function that will be, of course, the mineBlock function. And this future mineBlock function that we're going to make, we're going to first solve the proof of work to get the proof, and then we will apply this createBlock function because we will have all the key informations of the block that we need to create a new block.